Welcome. So today we're going to stand up an AWS EKS cluster using eksctl, and we're going to make it auto-scaling. Because that's going to take a little while, I'm going to go ahead and get started right away with that, and we'll take a look with what else we need to do and how we set it up after I get it started. So I'm just going to kick this off with a configuration file and let that run. And that's going. That's going to take a little while to go. I'm actually going to scroll that a little bit smaller so it doesn't wrap as bad. We can see it a little bit better. But it's deploying. Let's go ahead and take a look at what that looked like. There isn't much to the configuration file. The command I gave it was just eks create cluster and gave it the file. And here's the file. So it's a normal header for eksctl, calling the cluster sandbox. It's in US East 1. I'm turning on CloudWatch for it for all types of logging. And then it has one managed node group, which is ng sandbox. It's running M5A larges, which are a little bit cheaper than the M5 larges, which is eksctl's default because they're running on AMD. And it's got anywhere from 2 to 5 nodes involved. And to make sure it will work with autoscaling, I've gone ahead and set the IAM policy to just give it autoscaler requirements. And that's all there is to it, right? That's going to get started. It should take about 20 minutes to start up. So I'm going to let that run. Some things that I already had set up before this got started is I had AWS CLI installed. So I can see that I'm connected. And I have kubeconfig installed. There shouldn't be any nodes yet. Oh, it does have a node. Oh, that's my own local node. So that's not, there's no EKS eksctl node started up yet. That's my local practice node. So we'll have to wait for a little while. But I do have kubeconfig installed. One thing I don't actually have installed is eksctl, even though I ran the command. And actually, we can take a look at that. If I do go ahead and show it. What I actually have is a wrapper script that just uses kubeconfig's directory for the configuration file, checks to see if I have an AWS profile set, and then just runs a Docker command to run the eksctl off of that, which just makes it easier to run for me. I can update much quicker, and it just has some volumes that are pointing to my AWS configuration, my kubeconfig configuration, and my local directory as a work directory. So that's really all there is to it. I can do and see that it's an up-to-date version. So okay, this is going to take a few minutes to run. Yeah, we'll just let it run. I'm going to go ahead off camera while it does so. And then we'll come back when the node is stood up. Okay, so the cluster stood up. It says it's ready, and if we were to go ahead, slightly bigger screen here, and let's do kubeconfig get nodes, we actually see that we get an error in the kubeconfig configuration, and it really just says that although eksctl wrote the authentication piece out, it set it up for it set it up for v1 alpha 1, and it needs to be v1 beta 1, and it's easy enough to change. If I just go in and see where it set it up, Well, actually, the other way around. I guess it was set up for beta. It needs to be set up for alpha. And this is just using the AWS-iam-authenticator. So I can go ahead and set that. And now if I do a get nodes, I see it works, and there were two. There's two ways to fix it. One is just do that manual edit that I did. The other is you can just use, there's a AWS command where I could just actually do an update kubeconfig and give it a name of the cluster, which would be sandbox, and run it, and it would just go ahead and put another context in, slightly different, but it would use the AWS EKS get token instead of the AWS IAM-authenticator, which means I wouldn't have to have that installed. If I was going to do that, I would have turned off the kubeconfig update on the EKS CTL command, so just so that I don't have two copies of the same configuration in my config. But in any case, we have two. That's great. If I go back and let's look at the config again, we see that the min size was 2, which is what we're at. We're at 2 nodes, but it can go up to 5. And we set it up to have the IAM for Autoscaler, but what we didn't do is actually put the Autoscaler in place. Cluster Autoscaler is something you need to separately add on. It goes in as a deployment, and it comes right off of the Cluster Autoscaler GitHub account, and I can just grab it. I'll scroll back through it really quickly. The big thing is you don't need to spend much time to it. It sets up a service account and a cluster role with all the groups it needs. It sets up a role for it, sets up the binding to the role, sets up another role binding here, and then it actually does the deployment of Cluster Autoscaler. Everything can be left as is, except that I need to use the image for Cluster Autoscaler that matches my version of Kubernetes, which is 1.23. I can see that over here, that it's using Kubernetes version 1.23. So I use the latest 1.23 release, which happens to be 1.23.1. The other thing I need to do is down here, there's this gets mounted the right place for Amazon Linux. There's a comment that I took and put in place to get the right one in the one I downloaded, and then you have to set the end of this line to be your cluster name. So since the cluster sandbox, that's there, and now I can just kubectl apply -f cluster autoscaler autodiscover, and what this is going to do is since the EKS-CTL configuration knew that it was an autoscaling cluster and it's a managed node group, it went ahead and tagged everything the right way so that this, the cluster autoscaler can find it because it finds this tag on it. So, since it knew that, it's already an autoscaling group in EC2. Now Kubernetes knows how to autoscale it. So, anyway. So, wouldn't be very good demo if we didn't actually try it. The first thing we need to do is get some sort of deployment. Let's just get nodes. All right, and we see that it just has the 2. I'm just going to remember the last digits here, 9 and 52, just because it'll make it easier to see. And let's go ahead and do a deploy. I'm going to deploy the Weaveworks sock shop because it's good microservices demo. So I have it checked out here. So if I go microservices demo, deploy, Kubernetes, and from here I can just do a kubectl apply -f manifests and apply that whole directory, and you'll see it go ahead and create all the deployments and services it needs. It's going to take a few minutes to stand up. So let's go ahead over here and let's do a Let's get pods in sock shop namespace. And we see they're all creating. This is going to take a few minutes until they get all done here. So I'm going to go ahead and jump off camera for just a few more seconds and we'll let this happen. Okay, looks like we got it all running. All the copies that are supposed to be are running. I'm gonna pop back out just to free up a little space there on the screen, and let's do a kubectl get pods again. Oops, not get pods, get nodes. All right, we still have 2. Okay, turns out that deploying this, even though there's a bunch of deployments and services, there's not enough to trip it over. 2 is plenty for it. So one thing we can do is scale it up. The first thing I can do is let's just take a look at the deployments that we have in the sock shop, and we see there's a bunch of them, and I'm going to be a little bit clever with this command. I'll describe it as it runs. It's the kubectl scale deployments in sock shop, and I'm going to run that command I just ran, this kubectl get deployments, but I'm going to return just this first row, so just the names of them, so it'll put them right on the line, and I'm going to scale them up to 6. Right now there's 1 deployment of each of them. I'm going to bring it up to 6. Let's go ahead and let that run. And we can see immediately there's a bunch of things happening here. Let them go ahead and get ready. In fact, let's go ahead and quit out of this. And let's watch the deployments. A little bit more interesting. See them coming up. All right. And if I get the nodes still at 2, let's clear that. Let's just see these coming up. Now it does take a few minutes because it needs to spin up new pieces of the node group, a new EC2 instance to handle it, or 2, as the case may be. You see the nodes are getting ready. You see it's changing a little bit slowly. Hopefully the nodes will get better. Again, this is going to take a few minutes, so I'm going to go ahead off camera again and just let this happen. Okay, that was actually quicker than I thought when it kicked off the 2 new nodes. You can see there's 4 nodes there. They're not all ready yet, but they went ahead and got started. And we could see more and more of the deployments are deploying. It's going to take a few minutes to get that going, to get that finished rather. But you can see that the nodes are ready now. And that was it. We just scaled up from 2 nodes to 4 nodes when I scaled up my number of kubectl deployments to handle the load. Now, if I was to combine this with the horizontal autoscaler, I could make these deployments so that as they took load, they scaled up. If they scaled past the point where I didn't have enough nodes or didn't have enough space on the nodes, usually run out of pods, because there's a maximum number of pods per node. On this, I think it's somewhere around 30. But as soon as I got to that point, it could go ahead and it could kick that off, and I could make it completely automated based on load. In this case, I forced it by actually doing the scale to scale it up. That's really all there is to it. These are still getting ready. They're still going to take a few minutes. So let's let that go. Okay, everything stood up now. We got 6 ready. We see we only needed the 4 nodes, but we got 6 deployments of each ready. Let's go ahead and shut this down. Let's just see how it works if I was to scale it back. Let's cut it back to 2 replicas. Do the same trick. We should see them. Go ahead and scale them back. We see it terminate a bunch. Right? We already got 2 available. If I do a kubectl get nodes, we still got 4. The reason is fairly easy. If I was to do a, let's go ahead and do a kubectl get pods. I don't know if that will show very well. It doesn't really, but you can see that there's a couple different nodes being used, right? We got 127, 9, 52, 83. So those are all my 4 nodes, right? 9, 52, 83, 127. So they're still scattered amongst them. So even though I scaled back, I would have to cordon off these nodes and drain them. And I think I probably can if we just do a kubectl. Try it here. I think I can just drain it. Oh, it's got a daemon set on it, so I'd have to go ahead and ignore daemon sets because daemon sets obviously are deployed 1 per node, so there's no way just to drop that out. And then there's also a some persistent data stores that were stored locally. It's probably a bad idea. It works fine for this sock shop, but I could have gone ahead and switched that over to an EBS volume so that this wouldn't happen. But I can go ahead and set those. It's going to go ahead and evict those. All right, and we can see it went ahead and did some changes here because those had to get moved over. Now we can actually do some planning to do pod disruption budgets and stuff like that. Right, so now I could go ahead and shut that down. Let's do the same thing with 52. We see again a little bit of blip. It's evicting them. And I can see now I have 2 that are ready, 2 that are not being scheduled. So those original 2 I happen to pick. I can go ahead and turn those off now because I don't need them anymore. And we can see these will pop right back up to be deployed on the 2 existing nodes, so you can scale back. And like I said, we could do some pod disruption budgets to make sure that this didn't happen where we'd end up with 0 ready and the system was actually down just because we were scaling back. And we can do some things to make this more dynamic. But for now, that's all I really wanted to show you, is that I can spin them up, I can spin them down, and I can go ahead and drain them so that I can shut them back down. Hope this was useful. Thanks.